Today we are going to talk about what is the possible error we can make in the bidirectional BFS search in the WordLadder or any Bi-BFS, bidirectional BFS. First, my order is pop from the frontier, then check the goal test, then generate adjacent. Let's think about there are two frontiers, forward frontier, backward frontier. From the forward frontier, I'm going to work first. I'm going to pop yes. Then I'm going to check the goal test. In the first goal test, I'm going to check if S is in the backward frontier, so G. It's not true. That means do the action. So S will expand, so generate adjacent. So I'm going to make A, B, and C, for example. Then in our pseudocode, what we did was go to the back frontier. Then what we did was pop goal test. So second goal test is checking if G is in the forward frontier, so A, B, or C. Actually, this is not true. That means G will do action. That means generate adjacent. So this time, what I'm going to do is I'm going to make adjacent as D, X, and B for grammatical movement. Go back to the frontier. Now, frontier, we're going to pop. We did pop. Actually, this is not really good, but A. Pop A. So then goal test. The third goal test happens here is if A is in backward frontier, so D, X, or B. It's not true. So what I'm going to do is generate adjacent from A. So let's just make like D and E, for example. D and E are added to the forward frontier. Next step, if I pop D, what will happen? If I pop D, then in the fourth goal test, it's going to check D is in forward frontier. So B, C, D, E. Oh, this is true. D is in forward frontier. So finally, what will happen is it's going to make the final path as S, A, D, and G. Path length 4. However, see here, there is a B, there is a B. So actually, real shortest path for this graph was S, B, G. Unless, how can I avoid this problem? Before you pop D, now pop D will be not number 4, not step 4. What we are going to do is pop A, then check. Pop B, then check. Pop C, then check. So make the forward frontier expand one full level. Then go to the backward frontier, then expand one full level. If I do that way, because I do not pop D from the goal, what will happen is it's going to go to the B, then pop B, then check the goal test, then it's going to find the shortest path. So after pop A, pop B should be done, not pop D. So now let's apply this one to the code. This is the BFS code. Bidirectional BFS, I rewrite. First, I have a frontier from the forward and backward. then explore the front, forward, backward. That is exactly the same. And while both frontier is not empty, are not empty. First, we're going to think about the depth, or like what is the all the nodes on the current frontier, so current level. I actually did decopy into the temp list, but whatever my current frontier has, that is the current level, like ABC. That means when frontier has ABC, now temp has ABC. This one. Then I'm going to check only temp. So whatever I expand, like a DE, let's say X, Y, Z, W, they will be added to the frontier. So F frontier. So for the frontier will restart empty because I gave to the temp all the values to the temp. And while temp is not empty, pop it from the temp, so A will be popped. Then check the goal test. If it's not true, then generate adjacent of the A, so D and E will be generated. And you are going to add D and E to the frontier. So frontier currently have only D and E. Next time, B will be popped from the temp. So this one, these are what temp has. Then the next level is what final new frontier has. So after you are done working on the one level expanded from the frontier forward frontier, now we are going to do the exact same thing to the backward frontier. If we look at here in the backward frontier, now temp will have what backward frontier has. Let's think about the backward frontier has like level 1, 2. Then it's going to go to into the temp. Then frontier is empty. While you are going over the temp first, top D, then check the goal test and extend. So generate adjacent, then those adjacents will be added to the frontier. So frontier will have only the generated adjacents. So we are going to keep doing for the frontier, work on everything, then go to the backward frontier, work on everything. So expand the whole level until you are going to find a final path, shortest path. And you are not going to have any problem finding the path in the middle of the work. Let's think about one more thing here. This one is exactly doing the same thing, just the name is different. So identical. So how about if we use some way to shorten our bidirectional BFS? First, I'm gonna have now only frontier, but frontier has forward and backward in the same place. Explored also have a forward and backward in the same place. I need one counter. K will be 0 or 1. First time K will be 0, so I'm going to give a K default value as 1 because K will be recalculated each time. So this time K will be 0 because 1 minus 1 is 0. If K is 0, next time K will be 1 because 1 minus 0 is 1. So when K is 0, I'm working on the frontier. If K is 1, I'm working on the backward. Forward and backward. First, my temp will be the front frontier. The first time, the forward frontier. Second time, backward frontier. Copy that, then front frontier will be empty. And while temp has something, then pop it, then you're going to check the test. But when you check the goal test, you are supposed to find if my current node is the other side of frontier. So 1 minus K will represent the backward frontier in this time. Now, when you work on for the explored and when you add to the current frontier, you are gonna just use K. Everything else is the same. So code becomes more compact. And this kind of scale will be used in our next lab, Lab 6. I hope you enjoy this.